Cool. Yeah. So good to see you all. It was great having all these presentations today. I was super inspired seeing everybody's presentations about 3D stuff, because that's what makes kind of this day really awesome. So anyway, I'm going to be talking on the art side about how I made some of this content. So a little bit about me. I mean, I've been at DGG only about, 6 months now? 9 months since October. And before that, I was 7 years at Wayfair, leading the 3D team there, kind of growing their team about how to make 3D content, both for rendering and real time. And then before that, a big background in game development. And then really excited, I've been part of the Khronos Group and been able to be a part of those calls ever since I joined Wayfair, which has been really exciting because I've been exposed to all of you, right? And all the really cool tech that's going on there. So I feel really privileged to be a part of that. And so I wanted to show kind of a quick video of like some of the content I've made. This is recently for the PBR webpage. That's the anisotropy lamp. And it's basically like when I submit stuff, I try to do a README for it that basically explains how I made it, to kind of explain it to others, to kind of train. We did clear code, so kind of trying to show that, the diffuse transmission thing, and fun to play around with animation features. I'm always trying to find ways to like show off this content and these features in glTF, like sheen and specular and material variance, and ways to show it off in a kind of a visually pleasing way, but also a great way to test it out. So all this content is available in the sample assets repo, and developers can use it to kind of test out their things like iridescence and again, clear code and metallic and transmission and volume and IOR and all that stuff. And animation pointer is a new one. So trying to figure out cool things, cool ways to use that. Trying to make really high quality assets to show that glTF can render really nice materials. And then like, this is one of the first ones I made, which is like transmission and volume and doing rough transmission, and then using material variance with emission to show on and off states, that kind of stuff. And so yeah, you know, I've basically been privileged to be a part of the sample assets repo and be able to submit stuff. When I first started doing content for it, it was a lot of like test models, like a single triangle or like a single quad or like, you know, a box animated. It's not that exciting, but it's great as a test asset. But I also wanted to like show off, hey, we can do really visually interesting things and really kind of also test out what's possible. How far can you go with PBR model and where does it break, right? That's always really interesting. But also like, how can we improve the authoring tools? So when you expose problems in the format, then tool developers come in and say, oh, well, you know, we can improve that, improve export tools and ways to generate materials, and ways to make it so that it's easier for others to use it. So that's been kind of my background too, is helping other people, artists, understand how to use this tech and make showcase content. So most recently, we revamped the glTF PBR website to kind of showcase, and I'm sure you've all seen it, but basically how glTF PBR works, and we tried to show elemental features of that to show like on and off, like how does emissive strength work without it and with. And then on my personal portfolio website, I added a whole bunch of glTF assets in there, and it all uses model viewer, which was fun to do. So why do it, right? Basically identified a need, right? Like we have all these sample assets. They don't look amazing. It'd be great to make amazing, cool assets that showcase and make it interesting to do. But being a part of those calls, I'm able to actually influence the standard and say, oh, you know, sheen is not really giving me the control I need in order to do real fabric. So can we add this extra feature? Or, but it's also like understanding what the tech is actually capable of. And so in those calls, I have access to Gary and I have access to Emmett and all these, you know, developers that know what the heck they're doing, and they can teach me how better to use the tech and how to understand it better. And then a personal brand, right? Like when I'm exposing this stuff, people then associate my name with this quality content, and it just elevates my personal brand, which is great, right? But I also get to train other artists and kind of help them grow and improve it, and that makes more content then for more developers to see. And then one of the nice things about it is that I get employers that are actually willing to pay me to develop this content. So it's a win-win situation for them because they get exposure and we get to actually test our actual software using these models. But it's also great because I get to make cool stuff because it's always really fun to make 3D stuff. So how do I come up with the 3D models? Well, basically it's kind of thinking through what's possible, like diffuse transmission. It'd be cool to figure out, how can we use it? Is it just sunlight behind a leaf and we show that green effect, or can we really do like, blood inside of a skin or interesting things like that? So like the stained glass lamp on the far right, it's cool with transmission extension. You can do a rough surface and you get a really blurry effect behind it. And that makes some really cool visual ideas. So I try to figure out, where would it be really cool? It'd be great if we could do heat refraction, right? And my first attempt at that was just rotating a normal map on a transmission glass surface on top of it. And it looked like a rotating normal map. It didn't look very great. So then I did an opposing rotation with a depth map, with a thickness map, with volume. So it rotates in the opposite direction, and the normal map goes in the other direction, counterclockwise. And because they're rotating in separate directions, you get kind of a moire effect or like an interference effect, and then you don't really see the rotation as much. So it's always funny to, try out things and see how far you can push them. Like the lamp turning on off was basically me baking lighting into an emissive texture and seeing how far I could push that. And then collaborating with developers, I get to basically influence how the tools work so that I can get new things, like working with Gary on diffuse transmission or, whatever the latest thing is, iridescence or something, and saying, oh, it'd be great if we could do this. Or most recently, it's been in the animation pointer extension. So I was testing out, UV translation of all the textures in glTF that you can translate. And it's like, oh, a couple of them just aren't working, but we can, work together and figure it out. And then I publish it on sample assets. And one of the cool things about that is I get all the developers coming in and saying, oh, well, this is wrong. This needs to fix. This needs to change. And that means I actually get to improve the content and make it even better. So that's always a great way to do it. And then, what's next? Like, it'd be great to do, we have the physics extension is under development. So I'm looking forward to testing that out and trying things out and seeing where it breaks and fails. And, I tried diffuse transmission with a volumetric surface like that orange, and it really kind of fails. It doesn't really work that well because diffuse transmission is a flat thing. It only happens at the surface of the model, and it doesn't care about what's inside the surface. So the orange really isn't that accurate because there's no calculation of what the volume is inside of it. But most recently, I think Ed Mackey at AGI was testing how can we use the volume extension with the diffuse transmission extension. And that kind of the next step towards subsurface scattering, which is really where you'll have more understanding of like, hey, there's stuff actually inside the surface. There's bone, there's tissue. There's other things happening that actually influence how the light is absorbed and refracted to the surface. So I'm really looking forward to seeing that improve and where we can push that. And there's just a whole bunch of stuff that's coming up. So it's always exciting to be a part of that because then I can come in and say, oh, have you thought of this idea? Or gosh, it'd be cool to do that. Or like animating things that's really cool to play around. And then it always influences how we share how to make this content. So the coolest thing about writing guidelines is that I learn what I don't know. Because as soon as I try to write it down and explain it, then I realize, oh, I don't really understand that. I thought I did, but now I'm trying to explain it to someone else and trying to simplify it and make it really concise. Then I realize, oh yeah, I just don't know it and I have to learn more. So that's really a great way. I just recommend it to anyone. Writing documentation and like explaining and doing tutorials is a great way to actually learn what's really possible, because then you realize where your gaps are. And then at DGG, we get to involve new tool development, which is great. So part of my role at DGG is leading the teams that handle conversion of materials from DCCs, or digital content creation tools, where you get a really complex node tree and you've got to collapse that down into something that works in real time. So we've built a tool over the last couple of years that basically converts from V-Ray into glTF, and it also does Remoto, the glTF and USDZ, and it also does, we're doing a Blender integration. So there's a bunch of different ways to do that. But it's great to be able to influence that and basically drive that direction. But I think that's basically it. Thanks.